International Mathematical Olympiad. Every year, from more than 100 countries, the 6 most talented students in mathematics are chosen to represent their nations. It's like the World Cup of mathematics. The exam is a very challenging test. That's why it is split across 2 days. And for each test, you're given 4.5 hours. So in total, you're expected to solve 6 problems in 9 hours. The problems are arranged from easier to harder, and the answers are never numerical. Meaning, when you solve a problem, you don't end up with a numerical result. Instead, you are asked to prove things. And for that, you need some very serious reasoning. For each problem, you can get at most 7 points. Therefore, the maximum score is 42. Today, we are going to solve the very first problem from the year 2019. In other words, the easiest problem. It says the following: let z be the set of integers. Determine all functions f, such that, for all integers a and b, f of 2a plus 2f of b equals f of a plus b. A beautiful question. All right, let's start solving. Let's put our problem in front of us again. Let it stay up there in the corner. As you can see, in this equation, we have 2 variables, a and b. And it doesn't allow us to do any direct algebraic manipulation, meaning I can't produce any information about how the functions behave. In such cases, you usually try plugging in some values for these variables to look for a pattern. For example, let a equal 0. Our equation was the following, right? If we plug in 0 for a, we get f0 plus 2f of b equals f of 0 plus b. And 0 plus b is simply b. This expression must hold for all integers b. In fact, why even call it b? Let's rename it x. Then the equation holds for all integers x. All right, but this equation didn't tell me much either. Let's also try a equals 1. If we plug in 1 for a, then the equation becomes f2 plus 2f of b equals f of 1 plus b. Again, this holds for all integers b. We can call it x once more. For all integers x, this equation is valid. Now look closely. This composite function here and the one above, they look similar, don't they? If in the upper equation I replace x by 1 plus x, then the expression becomes f of 0 plus 2f of x plus 1. Therefore, these 2 expressions are equal. And there we go, we found our pattern. There's useful information here. Notice that f2 and f of 0 are actually constants, right? While the other 2 are just normal functions. So let's gather constants on one side and functions on the other. On the right-hand side, I can take 2 as a common factor, and then divide both sides by 2. Now this is actually a very informative equation. On the right side, we have the difference between 2 consecutive terms, f of x plus 1 minus f of x. And on the left, we have a constant number, which is f of 2 minus f of 0, divided by 2. When is this possible? I mean, for what kinds of functions do consecutive terms have a constant difference? Of course, for linear functions. Let me show you. I've drawn a coordinate plane. Here's what we'll do. We'll plot some points on the screen and make sure that the difference between consecutive terms stays constant. For example, let's place the point 1, 1 here. Then the point 2, 4 here, so the difference between the 2 y values is 3. The next point would be 3, 7. Then 4, 10. I think you can already guess the rest. And look, if I connect these points, I get a straight line. So we can say that the function f of x is linear. The equation of a linear function is mx plus n. This part is actually the most critical moment of the whole problem. Now, all we need to do is plug this into the original equation. F of 2a becomes m times 2a plus n. 2f of b becomes 2 times mb plus n. And inside f of a plus b, we also put the same form. Plugging that last piece back into the formula again, we get this. If we simplify the left-hand side as well, we arrive at this final equation. Now look, on both sides we have the term a plus b, so their coefficients must be equal. For the constant terms, on the left we have 3n, and on the right we have mn plus n. These must also be equal. If m squared equals 2m, then m is either 0 or 2. If m equals 0, then plugging it into the second equation gives 3n equals n. That means n must be 0. If m equals 2, then the equation becomes 3n equals 3n, which holds no matter what value of n we pick. So in the first case, m and n are both 0, which means f of x equals 0 satisfies the original equation. In the second case, m equals 2, and n can be any integer. Therefore, f of x equals 2x plus n. And you can substitute any number for n. Yes, that's the full solution. We earned 7 points. We solved one problem from the hardest test in the world. I hope that was clear. See you in the next lesson.